everybody, meteorologist Liz McGiffin here, and since June 1st marks the official start to the Atlantic hurricane season, I wanted to show you a really easy experiment that you can do at home to kind of talk about hurricanes and how they form. So here's what you need for this. You need food coloring. Really, you just need one drop, so just pick your favorite color. You need a large bowl, at least a medium to large bowl. Bigger is probably going to be better for this experiment. You need some water, and I'd grab a spoon or something that you can stir with. The first thing that you need to do, and I've already done this step here, is fill your bowl about 2/3 of the way full with water. I also went ahead and did one more thing. I put a white piece of paper underneath this because when I give you a bird's eye view here in a couple minutes, you'll just be able to see the contrast a little better. Now the temperature of the water for this experiment, it really doesn't matter, but for the purpose of this being a hurricane experiment, I'd recommend getting some warm water in the bowl. The big reason for this is because hurricanes thrive, just like thunderstorms, off of three key things: lift, instability, and moisture. And since hurricanes typically form where they can find all three of those at one place, that involves warm water. In our case, we're talking about the warm water in the Atlantic, especially as we head toward the end of summer and the beginning of the fall months when the water is typically at its peak. Next thing I'm gonna have you do is grab your spoon, and if you can't find a utensil, honestly, you can even use your finger to stir this around. I need you to start stirring the water all in one direction. For this purpose, it doesn't really matter which direction you go, you just need to make sure that you're spinning it all in the same way. The reason that we're doing this is because a hurricane or a cyclone or a typhoon, all the same things depending on which area of the world you're looking at, they're defined by the same way. They start out as an area of low pressure, which low pressure in the northern hemisphere, we can find that on a map by wind that moves around in a counterclockwise motion. If you stir around in a clockwise motion, well, you're just giving yourself an area of low pressure that happens in the southern hemisphere. There isn't really a strict time limit for how long to stir this, but the idea of this is to create enough circulation that the water can move on its own. I wanted to change views for this next part so you can get a better feel for what's going on in the experiment. You want to make sure that the water is spinning around just enough so it can be sufficient by the time you pull out the spoon or whatever you're stirring with. What this represents is a strengthening storm. So in order for a storm, like a tropical storm or a hurricane, to get a name, we need to hit wind speeds sustained or continually at 39 miles per hour. Once wind speeds hit 39 miles per hour to 73 miles per hour, you have a tropical storm. And once those sustained winds work their way all the way up to 74 miles per hour or beyond, that's when you have a hurricane. Now, obviously, we're not trying to attain that sort of speed with this experiment, but you get the idea. Next thing I need you to do is take your food coloring and just need to add 1, maybe 2 drops in there. And now we watch and see what happens. You'll notice right away that there's not just a drop in the middle, it's kind of spiraling out. What you're looking at the very center of this, how it creates almost a little circle before spiraling out, that represents the eye of the hurricane, which can actually be the calmest part of the storm. Now, just outside, you can almost see that clear circle that's forming in the middle. That would be the hurricane's eye wall. This is actually where you can get some of the strongest winds and tightest rotation. That's where we're kind of measuring that 74+ mile per hour wind speed in a hurricane. You'll also notice that it completely spirals out away from the center of the storm. That is the first thing to make its way on shore as a hurricane starts to work its way toward land. This normally shows up as bands of thunderstorms. And these thunderstorms, they can be strong and even severe, producing some very heavy rainfall, thunder, lightning, strong gusty winds, and even tornadoes. I want to keep this on here for a minute too, because you'll notice that as the wind speeds die down, well, you don't have quite as clear of a definition of those spiral bands as well as the eye of the storm. This also represents what happens after a hurricane makes landfall. Remember how we said those 3 key ingredients were needed to keep a storm going? Lift, instability, and moisture? Well, as soon as the hurricane works its way away from the ocean, we cut off that moisture source. And lift, it's influenced by warmer temperatures. And a lot of times after it rains, you probably step outside and notice the cooler temperatures. So those rain bands that go ahead of the storm can sometimes get rid of a lot of our instability. And eventually, the hurricane will work its way on land as a normal area of low pressure and kind of rain itself out, like what we can see here. And in the experiment, that just means that, well, we're going to end up with water that's a different color.